Hello students, today I am going to start with the remains of the chapter Chemical Kinetics, and our today's motive is to score 2 more marks from the chapter. As in previous lecture I told you how to secure 3 marks using numericals and formulas. Remaining 2 marks question comes from this topic. This is on the board right now. In the next topic I will tell you about starting of organic chemistry with important name reactions. This also comes directly in 2 or 3 marks in the board exams. So let us start with first important definition, rate law. This is a law given for the rate of reaction and according to which the rate of a reaction is directly proportional to the multiplication of concentration of each reactants raised to the power which are determined by experiment. Means if A moles of A, B moles of B forms any product, the general reaction, then rate is equal to K into A raised to power alpha and B raised to power beta. Alpha and beta are determined by experiment. These are not A or B, means not stoichiometric coefficients. And this proportionality constant is called rate constant. When concentration of each reactant is unity, 1 mole per liter, then rate is equal to the rate constant. This is definition for rate constant. And sum of these powers alpha, beta and gamma is called the order of reaction, which may be positive, negative, zero or fractional. Means zero order, first order, second, third, like this. The unit of rate of a reaction is moles per liter per second, as rate is equal to concentration by time change. So concentration moles per liter and time second inverse, or if pressure is taken then it becomes atmosphere per second or bar per second. But unit of rate constant K depends on the powers alpha and beta. So the formula comes 1 upon time into 1 upon concentration or pressure raised to the power n minus 1, where n is the order of the reaction. Unit of time second, unit of concentration moles per liter, and unit of pressure is atmosphere or bar. So putting the value, we get for first order n is equal to 1 and unit is second inverse. For zero order, this will comes to be moles per liter per second or atmosphere second inverse in case of pressure. For second order, it will become liter mole inverse and second inverse, or atmosphere inverse second inverse. And for third order, putting the value 3, it will become liter scale mole inverse scale second inverse, or atmosphere inverse scale second inverse. Same way, whatever the order, put the value in the formula and calculate. This type of question comes. It will be explained in the forthcoming lecture. Now, molecularity. According to collision theory, molecules when collides, then reaction takes place. So this is the number of molecules minimum which must collide to result into a chemical reaction. Molecularity can be 0, 1, 2, 3, 4, so on like this. And there is no relation between the order and molecularity, which is sometimes expected. They are different from each other. Number 6 is collision frequency, Z. According to collision theory, when collision takes place per unit volume and per second in a reaction mixture, then this number is very high, which is from 10 to the power 25 to 10 to the power 27 collisions per second. This is called the collision frequency. And activation energy, this is according to transition state theory, and according to which the energy absorbed by the reactant to result into chemical reaction or to make their energy equal to the energy of transition state so that the reaction can take place. This comes by this graph, the energy profile graph. So in this graph, if this is the energy of reactant and this highest is energy of transition state, then this difference is called as activation energy. And last one is the T half or T1 third, T1 fourth. This is the time taken for 1 half or 1/3 or 1/4 reaction to complete. Means if 1/2 means this is the time required for half of the reactant to react completely. If 1/3, so this is the time taken by 1/3 of the reactant to react, means half is equal to 50% substance has reacted. If this is equal to 1/4, then 1/4 of the substance has reacted completely. The question comes in this form. These are the various forms of questions. First one, like Rate of reaction will be given K into A raised to power half B raised to power 2. Calculate order and unit of K. Simply, these are the most simplest question. If you use the techniques, order is equal to 2 plus half, or half plus 2, 2 and half means 2.5. And put the value in the formula. The unit of K will become mole, inverse, liter, 1.5 and second inverse. Simply, if you are given sometime unit or you are given rate constant K, this one moles per liter or whatever, then how to find the order in reverse? Order is equal to the power of liter plus 1. For example, in this case 1.5 plus 1, 2.5. Here 1 plus 1 is equal to 2. And if given in atmosphere, then the answer will be add 1 in the power of atmosphere and remove its negative sign. For example, 2 plus 1 is equal to 3 and remove the negative sign. Also, the rate of reaction is equal to change in concentration given negative sign because concentration decreases, as will be explained here in numerical, upon change of time, or change of concentration of product by change of time. They are having only positive and negative signs, which is a difference. If concentration of reactant is 5 moles per liter initially and after 10 minutes it becomes 3 moles, then what is the rate of reaction? Is equal to R2 minus R1 delta R, 3 minus 5 upon time 10. So 2 by 10, 0.2 moles per liter, and minute inverse will be the answer because the unit is given in minutes for 10. So 0.2 moles per liter per minute are consuming with this speed, and there will be negative sign obviously. In terms of product will be positive sign, and positive, negative, this simply means that the substance is either decreasing or increasing, nothing else. Number 3, general reaction A moles of A, B moles of B form C moles of C and D moles of D. Then rate of the reaction will become equal in each term when the rate of A, dA by dt, small change in A by time, divided by its coefficient A, is equal to either 1 upon B dB by dt or 1 upon C small c dC by dt and 1 upon small d d capital D by dt. These are the rates of reaction. But if we remove the A, B, C and D, means dA by dt, dB by dt, dC and dt by dt, then this becomes the individual rates of A and B, C and D respectively, because they are not reacting or consuming or forming at the same rates. They are having different rates. If 1 mole of one is decreased, 2 moles of other are formed. So that is 1 mole per liter. If then there will be 2 moles per liter will be forming. So this is made equal and called rate of reaction. Question comes like this: the rate of A is 5.6 10 to the minus 3 moles per liter. Means dA by dt is given rate, complete value of this 5.6 10 to the minus 3. Then what is the rate of reaction and rate of D? So according to equation, rate of reaction is equal to dA by dt divided by A. The value of this complete dA by dt is 5.6 10 to the minus 3 upon A, whatever given in the reaction, divided. And rate of D, according to this, dA by dd by dt is equal to, D will be here, D upon A into dA by dt. So D upon A into dA by dt value is given 5.6 10 to the minus 3 in moles per liters per second. You will get the answer. So guys, from this topic we have completed with the very important topic, and to secure complete 5 marks from the chapter chemical kinetics. And in next lecture I will tell you about the important name reactions, out of which 100% there will be question of 2 or 3 marks directly in the board exams. And also whatever the topic I have told you, they will also come in the same way, and I will keep on continuing with some other topics also. So next topic will be important name reactions from organic chemistry. Thank you.